How is everyone doing? Really? I came all the way from California. Do you know how long that 45-minute flight is? How is everyone doing? Awesome. So I feel a little bad because my first slide was introducing myself, which is now pointless. But the one thing I do want to highlight is that there's no relation to James Dean in my last name. So if you want to connect with me with any of the code I show you today, or connect with me on Twitter, Instagram, you can follow me at JLDean. Super easy to remember. And before we dive into today's actual session, where we're going to talk about containers and master tooling and DevOps, I want to make sure that I set the stage appropriately. We really only have about 60 minutes, and really, after introductions and some talking, it's about 58 minutes at this point. So I want to make sure that we level set our expectations appropriately. This session was specifically designed to get you thinking, to get you excited about maybe what's possible, maybe things that you didn't know about before, and it's going to give you resources to learn more. But it is not intended to make you an expert. One of the things I used to ask my dad when I was a kid was brain dump. Just give me everything that you know and just dump it over. And as we all know in tech, it doesn't work that way. We have to learn. So I want to show you some high-level tools, and then we all can learn together. And now leading into our actual session, I want to talk about the state of our industry, right? Because if you work in tech, which we all do since we're here, we know that technology is changing, right? There's a shift that's happening. Technology or IT or development 10 years ago doesn't mean the same as it means today. And I love this quote by Monty C.M. Metzger because it really explains just how our industry is changing, but from a monetary perspective, from a business perspective. Uber, the world's largest taxi company, owns no vehicles. Facebook, the world's most popular media owner, creates no content. Alibaba, the most valuable retailer, has no inventory. Airbnb, the world's largest accommodation provider, owns no real estate. Welcome to the digital economy. Welcome to our changing and growing technology industry. So for those of us who are developers or operations or jacks of all trades, how do we scale with this demand? How do we meet our business demand and our customer demand to compete with this level of growth? The first thing we have to do is we have to listen to the people involved. So just by a show of hands, how many people in the audience would feel comfortable identifying themselves as a developer? Awesome, like 85% of the room. How many people feel comfortable identifying themselves as an IT pro or systems administrator or operations? Okay, less hands. And how many people wear whatever hat their boss tells them to wear that day? Everyone's hand should go up, or I need to have a conversation with your boss. But the point is that we all kind of fit into a certain part of this equation, and we all have our own feelings about perhaps the other side of the equation, especially as it relates to our performance and our ability to scale. So for the developers in the room, perhaps this sounds familiar. I need to create applications at a competitive rate without worrying about IT. And we all know the age-old saying, it works on my machine, it's your IT server that's broken. Or my productivity and application innovation become suspended when I have to wait on IT. Why won't IT just give me access to their servers, right? The common theme from the developer's perspective is IT is the bottleneck to their success. And if we want to scale, if we want to grow, we have to remove bottlenecks. Now don't worry, remember, I spent 10 years as a systems administrator, so I'm going to get to the operations people in the room, all 5 of us. For the operations people, this is our perception. I need to manage servers and maintain corporate compliance with little disruption. I can't just give you unsolicited access to my servers. But because I'm not innately a developer, I'm also unsure of how to integrate unfamiliar applications. I have to work with you. I want to work with you. But I'm unable to focus on both my server protection and my server security, as well as your application compliance. So when I do work with you, if I point out an area for improvement in your code when it comes to security, we're just trying to work together and collaborate. But if we don't work together, then equally, from the IT perspective, the developer is also the bottleneck to success. And if the developer and the operations people are both bottlenecks to each other, we can't get anywhere. We're at a stalemate, and we can't scale and we can't grow. But if we shift the way that our mind works and we look at things as universal problems and shared problems, we realize that IT stress points doesn't just mean the IT pro stress points. It's information technology. It's technology. It's if you touch software, if you write software, if you support the infrastructure software runs on. These are all of our shared stress points. We all have to focus on security. We all have to worry about efficiency. And we all have to support this rapid innovation and this changing digital transformation we're currently in. And that's what sets us up into the next part of our conversation, which, surprise, surprise, is not DevOps. It's cloud. Because why does everyone care about cloud? Why are we focusing on that? Before we even get into DevOps conversations, every talk, it seems today, has something to do with the cloud. I want to run containers on the cloud. But there's a distinct reason as to why we care about the cloud, because it's setting us up for success with DevOps practices. We all know the traditional cloud, right? It was traditional infrastructure for each application, which meant it was purpose-built hardware for each application and each project. The infrastructure and operations teams you had were distinct and separated. In DevOps, we call those silos. In my analogy, I like to say it's like a sixth grade dance. You have people on one side of the room, people on the other side of the room. It's incredibly awkward to come into the middle. And the processes and configurations that you have are customized and tailored. But customized and tailored processes don't scale. They don't account for unexpected growth or unexpected transformation. But cloud does, because now we're kind of steering away from the monolith and going towards loosely coupled applications and microservices. Our hardware, regardless of what cloud you look at, is industry standard hardware. Our teams that write code and support infrastructure are now service focused as opposed to project focused or application focused. And we call those service focused DevOps teams, which removes the silos, gets rid of that wall, and really has a unified shared support. And the process and configurations we have are standardized across the board. And we'll talk about how those standardized practices, based on DevOps practices, bleed over into containers and can help you master your container workflow. So now that leads into DevOps. And it's interesting that Brian opened up with a quote from my boss, because in every presentation I have a little South Park character of my boss. And he wrote this quote, and we love it. What a lot of people don't know is that he actually spent 30 days laboring over every word in this, because he wanted to make sure that himself and his team could stand behind it. We're incredibly passionate about the definition of DevOps. So DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The most important word in that definition is value. If you're not delivering value, what are you doing and why are you doing it? More importantly, do you know if you're delivering value? How can you gauge if you're delivering value? Do you have metrics and telemetry and monitoring set up to give you insights into your applications to help you determine if you're delivering value? Can you take that information, bring it back over into your sprints, and plan your next release cycle? More importantly, can you have insight into maybe your containers to gauge if you're delivering value? This is all part of what we're going to talk about today. So we've all heard standard DevOps practices, right? We know IAC, infrastructure as code, keep our source control or our application code right next to our infrastructure, all versioned together. You might also hear pipeline as code. It's becoming a little bit more popular. So you have your pipeline, typically in a YAML file, or Groovy if you love Jenkins. And you keep that, again, checked right in along your source control. And then once you check something in and push it to your source control repository, you have a build and release pipeline. Maybe that's stages, maybe that's Azure DevOps with build and release segments for your continuous integration and your continuous deployment. But a lot of times the conversation kind of stops there. I love when I get into a conversation with somebody and they're like, oh, I've adopted DevOps. I use a Jenkins build server. I have CI/CD. It's not all there is, right? We also have to account for automation. And not only automation in the ability to roll forward and keep our momentum moving, But in the event that there is a disaster, can we fail fast, recover, and roll back? That's another key aspect of DevOps that we have to consider and we have to talk about. Can't just be all roses and butterflies. Monitoring is another part of it, and that's that value piece. With availability and performance, we get things like telemetry and metrics that can give us insight and will influence the other three categories. When we can see what our users are using or what errors they're having, we can adjust our infrastructure as code or our source control in general and account for that in our build and release and account for that in failing fast or moving forward. So now that we've talked about cloud and DevOps and our changing industry, why do we care about containers? Why is that such a hot topic? I have gotten accepted into conferences with this title, Microsoft Linux Open Source DevOps Containers. Why? Because it's a hot topic. They're buzzwords, but why? We identified problems for the developer and the operations person early on in this session. For the developer, it now solves that bottleneck. We have this enabled, write once, run anywhere application ability, which in turn sets us up for microservice architecture. It makes it possible, and it makes it scalable. For operations, the primary and fundamental benefit is portability. Because now in a container, I have something that's immutable. I have something that's an entirely encapsulated runtime that I can put anywhere. So as a result, I now have standardization across my different environments. Doesn't matter if it's dev test, QA, canary, production, that immutable portable piece is going to run the same anywhere. And more importantly, from the developer perspective, it'll work the same on the developer's machine and in my standardized environments for my servers for our end users, which offers abstraction, right? Now I have a higher level of operating system abstraction, gives me a higher compute density, and it gives all of us the availability to scale. They're key components to DevOps practices. It's central to the theme of DevOps. But what's a container? Because everyone kind of knows, okay, well, I do Docker run, I'm running an image. But do you know the technical underlining components that makes a container? First off, I love blowing everyone's mind when I say this. A container is not a real thing. It's not real. What it is it's an application delivery mechanism with process isolation. And if you come from the Windows world, certain words you might hear in containers and Kubernetes are going to sound a little weird. Frankly, because containers were based on key Linux kernel features and not Windows kernel features. So we have to start identifying common words you'll hear. For one is namespaces. You'll hear that a lot with Kubernetes. That's what a process can see, or can see. That is your mounts, your networks, your C groups. C groups is what your process can use. That's your hardware. That's things like your memory and your CPU. And if you're already familiar with Kubernetes, it won't come as a surprise because you've probably also seen things like resource requests and limits. And that's where you actually set the bare minimum that your application needs for CPU and memory, and the max that it needs, and how much you should not be exceeding this amount, both of which are best practices, by the way. But these are key words that you'll learn as you start diving deeper into containers. But how does a container differ from virtualization? We all know the two common types of virtualization, right? You either have a hypervisor that sits on top of an operating system, typically Windows Server, Hyper-V, or you have a hypervisor that sits on top of your bare metal. Maybe that's VMware, ESX, ESXi. But in both situations, you have another guest operating system that sits on top of that. And then you have any of your binaries and your libraries and all your dependencies and your applications, and they all sit on top of that virtual machine. But they can change from one environment to another. You can have 4 different versions of Java that you need for different applications, but if you don't have the servers running it, you're going to have a problem. Container solves that, because whereas hardware, or the previous kind of virtualization was hardware virtualization, containers is more of an operating system virtualization. You're virtualizing the kernel. So now you still have infrastructure, you have your host operating system, and regardless of whether you're using Kubernetes or Docker, you still have the Docker engine, which enables your container runtime. That sits on top of your host operating system. And then within your container is that encapsulated runtime environment. I can even do a multi-stage Docker file to set my build with my SDK, what's needed at build time. It's probably not needed at runtime, so I just copy that in a second stage and publish that container with my runtime and the output from the first stage. It makes it portable, immutable, lightweight, better performance, chances are more security. So I have that encapsulated environment and I can run it anywhere and it's going to work the same. But that still doesn't fully explain what a container is, right? You might hear container layers. What are container layers? They're just individual lines that you have already defined in your Docker file. And once it gets built and produces that image that you run in a container, everything that was cached, all of those layers are read-only image layers. Your read-write actually happens in the container layer once you fire up your container and your application starts working. And by default, unless you've attached a volume, it's probably stateless. So then you can attach a volume to persist data. And all of this filters over into container orchestrators. Now, the advantage of containers, we've talked about again how we're trying to solve problems for developers and operations, trying to make sure that DevOps is really working together so we can meet this scale and this growth and continue to deliver value. So for the developer, I have fast iteration. I have agile delivery. I have immutability, which I would venture to argue is an equal benefit for the operations person. I want immutability. I want to make sure it runs the same way. It makes my time more efficient, and as a result, gives me cost savings in more than just a physical hardware kind of way. It also gives me efficient deployment. It's going to work the same no matter what. And we're not going to dive too much into this, but you can check this out if you want on your own time. Elastic bursting is another benefit of containers. I can go from private to public with a single command, or I can scale back down and go back to public to private. I can burst as needed on demand. So now the next thing I'm going to do, because as much fun as it is to sit here and look at me use hand motions and point at slides, demos are always way cooler. So I am going to get into a live demo. But I want to make one thing clear. Some of this demo might not make sense initially. It's intentionally designed that way. It's kind of designed to be like a bait and switch where you're sitting there at the edge of your seat, Michael Jackson emoji style, like, I want to know how she did this. This is awesome. But if it doesn't make sense, just bear with me, because we're going to go through some of that stuff afterwards. So I'm going to start off. If you were already familiar with who I am, i.e. you've followed me on Twitter and you've seen some of my demos before, you may have seen Croc Hunter. So Croc Hunter was, I love this demo, and I can say that because I didn't write it initially. I've taken it and bastardized it and made it just, I brought it around the world. But it was originally written by Lockie Evanson, who used to work for Deis, now works for us when we acquired Deis, and he actually wrote the very first Helm chart. And we're going to talk about Helm. But Croc Hunter uses Helm, and it's running on a Kubernetes cluster. Now you'll notice right down here at the bottom, I have some data. If I zoom in, I have a host name. If I keep hitting refresh, you'll notice how that host name changes, right? We have different letters at the end of the host name. Changes to 3 different names, depending on how many times I refresh. That's because I have 3 pods running on my Kubernetes cluster in Azure. It's 3 replicas of the same application. If one pod goes down, the application is still up and running. I have the release name, which is how you define your deployment for Helm. Helm is a package manager for Kubernetes, and we'll talk more in depth on that at the end. I also have my commit ID, and I'll show you my GitHub in a second, but that is the latest commit ID. So this makes it easy for me to see visualized changes, right? Especially in demos. But more importantly, let's take a look at how the game works. Of course, it's really awesome 1990s graphics. Half the time when the boat runs over the crocodile, it doesn't even count. I get to shoot crocodiles with fish. It's pretty awesome. But in my humble opinion, it's not awesome enough for Vegas, and it's definitely not awesome enough for VSLive. So we're going to make a change. Before we do, I promise to show you the commit ID, and we're going to zoom in here real quick, refresh real fast so you can see the latest commit, and we'll zoom right in here. So 718 is the prefix. I think we all can be in agreement that 718 is right down here at the bottom. So I'm going to go over to Visual Studio Code, and this was me sprinting earlier for those of you who saw. I wanted to make sure people in the back could see this one line of code. I ran for one line of code. I've run for a lot less. So we're going to just copy this, and right now this is my, so first off, this is technically a Go application, but it's a fake Go application. It's a JavaScript application wrapped with a Go web server. So this is the line of code that's actually choosing what you see from the game itself. So I'm going to go ahead and change it, and I made a game live 360. Bet no one can guess what that's going to be. But we're going to save it, and I'm going to have to zoom out here because I can't really see Visual Studio Code with that zoomed in. We're going to add, we're going to commit, we're going to push. Now, I already have DevOps practices set up for this demo. I already have a pipeline in place that's going to automatically fire off, and we're going to talk about that. So we're going to do live 360 demo. I'm going to hit commit. I'm going to hit push. Now, I have continuous integration set up, like I said, on this branch, and it's going to start firing off a release. So now that I pushed it, I should be able to go back over to GitHub here. We'll refresh. I should see a commit right here, and we see that it is orange. So we have something pending. Now, to see what's pending, I'm using a tool called CodeFresh. You can see that it's right here. If I zoom in, it's blue. For those that might be colorblind, this is blue and this is green, but blue means it's working, it's doing something. Now, I want to tell you about CodeFresh because it is a CI/CD DevOps tool, but it's specifically designed for Kubernetes. It's specifically designed for Kubernetes and Helm, and it helps you visualize what's going on. So if I zoom out and zoom in over here on the left, which we'll talk about, I have Devops Insights. I can immediately see what's running in my Kubernetes cluster. I can see my services. I can actually edit them right from the dashboard. Not that I would advocate that. All changes should be committed. But I can also see any Helm releases, which is the releases button beneath that. And we'll go into that in a second. First, I want to show you as the pipeline runs. And this is all in YAML. This is in my GitHub repository. There's a link at the end. But it cloned my repository. It's building my Docker image. Now you see a step that says promote to Artifactory. I'm not using Azure Container Registry. I'm using a third-party registry to store my Docker images. I'm using JFrog Artifactory. I'm doing that intentionally. Both my Docker images and my Helm chart is pushing over to Artifactory. And we'll take a look at what is actually getting pushed. But JFrog also has a binary investigation tool that will scan my images and make sure that they're secure and don't have any open vulnerabilities. So I can make sure that not only am I just deploying out a pipeline, I have Selenium tests that I can scroll down. You can see I'm running my Selenium tests right at this moment. And I have the image scanning that's happening. So the second my image hits Artifactory, X-ray starts. And because of the way CodeFresh is, I can go to my artifacts. I can zoom in here so you can see a little bit. Go to my image name repo. You can see the image that's promoted. And if I scroll over here to the right now it's still in progress. Once this finishes, I'll actually get rich links back over to X-ray and Artifactory. We can see that right here in my X-ray page. I'm already loaded in. So if I refresh, I can see I have 52 versions. I've done this release since I tested it this morning. I had 50. I've done this release twice now. Now, my one complaint is this isn't necessarily in date or numeric order, so I would have to scroll to find the particular release number. But that's not as important because all of them are checkmarked green. They're all scanned. I know that each change, no matter what, I don't have vulnerabilities in this image. I know that it's secure. And that actually references and ties back over to my Artifactory. So I can see I have a build name here. If I refresh, before the timestamp said 9:37, make sure that I'm signed in. And you can see the last build is 11:27. That was about a minute ago. I can click on this build ID. I can see that I'm publishing 2 modules. The bottom one is my image that I just made a new commit to, and we'll double check GitHub, make sure that that commit ID lines up. None of this is smoke and mirrors, this is live. But the other one is just a folder for Croc Hunter. I said I was also pushing my Helm charts to it. So if I scroll down, here's my tar file, which I can take my Helm chart and package it up because it's a package manager. That way I can easily share it. But I also have these files, which are actually my Selenium reports. So I can download my Selenium reports. We'll save it to my desktop. We'll open it up, zoom right in, and I can see all of my tests pass. So I know my images are secure. My Selenium test passed. I have confidence that this image is going to be, at the very least, able to deliver value in the sense that it works. So if I click out of this, I want to show you an X-ray real quick. If I refresh, I want to show you just the regular components. In the event that I had an image with a high vulnerability, it would actually tell me you have a high vulnerability. If I zoom out and I go into that, by the way, I'm using Debian to show you the high vulnerabilities. It's one of the reasons I usually advocate Alpine for base images if you can, when you come from the Linux world. And if this doesn't work, we'll actually just go back over here. That might be timing out. Gotta love conference Wi-Fi. I'll let that see if it spins. If not, the point is you can see it has a high availability, you can drill down into it, and you can see what the actual problem is. So if I go back over to commit, and we'll hit refresh, we see that the latest release was 1FE, right? That was what we saw before. If I go back over to CodeFresh, and I go to my builds, I should see that that's completed. I'm given all this rich information, assuming I'm not having a Wi-Fi issue right now. This is always fun. The Wi-Fi's down? All right, live failover on stage, hotspot. Give me a second. JD iPhone. That explains why things weren't working. There we go. I'm now linked. Give me a second. All right, refresh. And there we go. We're back up and running. Look at that failover. That's right. Didn't even break a sweat. Now let me see if I can actually get X-ray to load, now that I figured out that that was broken. Because I did want to at least show you the giant red code of, hey, you need to fix your stuff. Look at this. It tells you the severity. It tells you the media. Like, you need to have that insight so you can know what image you can go patch. And you shouldn't use mainstream. You use images that you control, that you run off of, that you own, and you take ownership for the security. So going back over to CodeFresh, I can see that the build completed. I can see the commit ID all lines up. I told you how it has Devops Insights. So I can go into Kubernetes. I have two different clusters in here. I do have a Windows cluster that I'm not using for this demo. And you're going to start to see a spoiler alert. I have a few different Croc Hunters because this is not the Croc Hunter I'm using for this particular demo. But you can see under OSCON CodeFresh, I have an image name, or the service name, and I have the image that's tagged with the appropriate Git commit ID. I can even see the services that are running and that the status is green. But more importantly, if I scroll over to Helm releases, because I deployed this using a Helm package, I can see all the releases that are also versioned and currently deployed on my cluster. You're also seeing a second spoiler. There's a Jenkins demo perhaps involved in this. So we can see that the last release was modified 6 minutes ago. I'm on revision 20. The way that Helm works is it marks everything. Revision 20, 21, 22. I can sit here and roll forward or roll back using Helm with one command. So it gives me that ability to fail fast if I needed to. I can click on the particular release and immediately see visibility into the services that are currently running on my Kubernetes cluster. This is visibility that I would otherwise have to get from the command line. I can see the history of all my different releases, and as a result, let me zoom out here, there's a little arrow off on the right-hand side here. I can click that and roll back to any of the other releases. I can see the components of my chart of what was used. And we'll talk about charts later on in today's session. Now, what I'm sure everyone really wants to know is, what is this awesome Croc Hunter app that you just made? Well, first off, it's a VSLive edition. But what is the weapon that I get to use for my Crocodile Dundee hunting? That's right, it's Live 360. But here's another part of the demo, and this is the parts that I've given you some spoiler alerts to. I get asked a lot, what tool should I use? I typically tend to show CodeFresh in these kinds of sessions because everything's really well linked. I can visualize the services that are running on Kubernetes. I can visualize my Helm charts. I have links back over to X-Ray and to Artifactory. But what tool should I actually use? The answer to that is you use whatever tool helps you deliver value. You use whatever tool makes sense for you and your team. Azure DevOps does the same thing. Jenkins does the same thing. And if you want to test out which tool or which option, which product delivers value, again, this is master tooling for containers, You don't have to just abandon what you're currently using. You can have things used simultaneously. Now, I don't know if anyone caught it, but when I started my demo and I showed you that everything was yellow, I didn't highlight over so you could see what was happening. And I didn't highlight over the yellow, and what I'm now going to highlight over is the check mark, intentionally. And that's because simultaneously, as my highlight is not currently working, let me refresh this. Gotta love conference Wi-Fi. All right. Still not working? All right, you'll take my word for it. When you do highlight over that, and actually I can click on it, there we go. I have 3 different build servers. So I had Jenkins, Azure DevOps, and CodeFresh all run this deployment. So we can go over to my Azure DevOps, refresh, and you'll see the change that I made. Live 360 is right up there. That build and release already happened. Here is, if I zoom in, this says ADO Croc Hunter. Zooming down, the host name says ADO Croc Hunter. We're going to go ahead and refresh this website. And that's now running Visual Studio Live. We'll go over to Jenkins. Make sure I might have to sign back in here. But okay, this commit ID right here, 1FE, that already fired off, completed 7 minutes ago. So zooming out, and we'll refresh right over here. And all of these are different DNS names, by the way. All the same release, different DNS names, different endpoints. All the same cluster, different container registries. I can manage all of that from different CI servers, different pipeline as code, and using a Helm chart. Because Helm charts give me variables that all I have to do is just parse in what I need for my release at any given time. So now I'm going to flip back over to PowerPoint, and we're going to deep dive into what actually happened so that we can kind of make a little bit more sense to this. So I have code on GitHub, right? And I use CodeFresh as my Kubernetes pipeline. That took care of my CI/CD. Then it took care of building my Docker image, packaging up my Helm chart, deploying out to Kubernetes on Azure, running my testing for Selenium tests, X-Ray, my Kubernetes repository for all of my artifacts, whether Docker images or Helm charts, was Artifactory and was linked over to X-Ray for scanning. But if this didn't make sense, you might be wondering, what is Kubernetes? Kubernetes is an open source container orchestrator. It was originally invented by Google, and it was actually based on the system that they used to run billions of containers per week. Their system was originally called Borg. This was donated to the Cloud Native Cloud Foundation from Google. It was specifically and intently designed to automate deployment, scaling, and management of applications. So it has some really key features, things like self-healing. So you saw in Croc Hunter, I have 3 different replicas. The way that it rolled that new update was it took the 3 replicas over here, killed one of them, rolled 1 pod of the new version over here. Once this one's healthy, kills the second one, rolls the second one over here. And then it waits for both of these to be healthy and kills the third one until I finally have a rolling update. It means that there's no downtime. It means that in the event that one of those pods fails, it'll quickly start over again. It's self-healing. It has automatic bin packing. Service discovery, load balancing, networking is built in. On all 3 of those different demos, they were not only DNS backed, which was a DNS provision I defined in my Helm chart. I have a deep dive 15-minute video on that on YouTube, but it also was backed by TLS. So they all had Let's Encrypt certificates that were issued by my Kubernetes cluster. Kubernetes is incredibly powerful. I could manage my secrets for all 3 different private image repositories. We know that using Helm, I can roll back and roll out new updates. And I could even, using Kubernetes, do horizontal scaling. So I can set up, based on CPU demand, I now want 10 pods of Croc Hunter. It's really powerful. And it does that using objects. So everything that you hear with Kubernetes is essentially an object, whether that's a deployment or a namespace, which we went over, ingress, which is how it was routing my traffic for the DNS names in Croc Hunter. You have replica sets, stateful sets, jobs. Jobs will start up, do a job. Once it completes, it'll kill. Then you have config maps and secrets. Volumes. I mentioned volumes very briefly earlier. That's where I could also attach a volume to my deployment, persistent volume, and make a claim for how much storage I need for my deployment. Once you've set up those objects, Kubernetes actually works using what's called a reconciliation loop. That's where the desired state, the state of the world that you want it to be. I said I want 3 replicas. Kubernetes reconciliation loop will keep trying to make sure that the actual state is in alignment with the desired state. So at any given time, whatever I've defined in code is what Kubernetes is going to try to make happen. It does that because it uses a declarative syntax. So over here on the right of the slide is, it's weird because that's my left, but on the right of the slide you'll see the deployment is the kind of object I'm creating. Then you have your metadata, and then you have your replicas. That's where you would define, you could hard code it, or you could reference it in a template. We'll show you that. And then down at the bottom is where you start defining your spec. You spec out what you want for your deployment. I say, okay, here's my containers, here's my image. I might also throw in there image pull secrets if I need to make sure I'm storing Docker registry information. And I have another deep dive video on how to do that. But once you've defined what you want, you give it to Kubernetes, and Kubernetes takes and says, okay, you want 2 replicas. I'm going to put it on 2 different node servers. If I wanted 3, put it on 3 different node servers. Typically, it's not going to put the replica on the same server unless you define or tell it to do so, or you don't have enough servers. But it's going to sit there and make sure that no matter what happens, it's going to be up and running. It's going to always try to make sure it's reconciled with that reconciliation loop. So the next question I get asked a lot is, who's actually using Kubernetes, right? Because it's still fairly new, and it sounds really great, but it also sounds really hard. Is it possible that companies are actually using it? Only a handful of small companies. Maybe you've never heard of them. GitHub, small little company with 27 million developers. Twitter, Spotify, Shopify. I love this next slide because I didn't know this until I saw it, but Pokemon Go is using Kubernetes. Walmart, Concur. So, I mean, this is something that is ready to use. But Kubernetes is a broad term because every cloud has one. So what is Azure Kubernetes Service, or Microsoft's offering of Kubernetes? First off, AKS is your Kubernetes cluster, and it's managed by Azure. So we take care of the hard stuff, and you only have to worry about the application part. What I mean by that is it's the fastest path to Kubernetes on Azure. I can run a container using Docker run, technically, using Azure Container Instances, which is technically backed by Kubernetes. But I don't have access to the cluster. I don't have management or control of anything. So if I want to control a cluster, AKS is the option. You can get up and running with 3 simple commands, and I like to argue it's technically 2.5 commands. And I'll tell you why on the next slide. And it uses open APIs. It is 100% upstream. What I mean by that is it's not a Microsoft fork. This is not a Microsoft version of Kubernetes that we've changed and manipulated. It's still full upstream, standard Kubernetes, and we just offer it on our service. It's easy to manage. You have automated upgrades and patching built right into the platform. You can easily scale the cluster up and down with 1 command. And it has a self-healing control plane. And we'll talk about what a control plane is in a few slides. To get started with AKS, like I said, it's 2.5 commands. This is using Azure Command Line, which is open source and cross-platform, works on Mac, Linux, and Windows. The first command will create your cluster. That second command is the halfway kind of command. If you already have the local binary that you need to interact with Kubernetes installed on your system, some people call it kubectl, others call it kubectl, pick a side and fight it out on Reddit. But that's the second command for your binary. Then your third command is to get credentials. That's what's going to actually take your authentication, set up your local system so you can interact and use the binary to interact with your cluster. This next page shows how easy it is to manage. So you can use the list command to get all your Kubernetes or AKS clusters, the upgrade command to upgrade to a different Kubernetes version, or the scale command to change from 3 agent nodes or workers to 10 or 20, depending on however many you need. And once you do, Azure will already take care of the linking, the management, the patching, the upgrades, all the complicated stuff that you used to have to do in unmanaged Kubernetes. So this side over here with the master VMs, the 3 different master VMs, that is your control plane itself. That's where your etcd, your schedule, your database, everything for the Kubernetes API is your control plane. So you would have to manage that, all hardware updates, all software patches, everything from more than just Kubernetes, as well as your worker pool and your essentially agent pool. But with managed Kubernetes of any kind, whether it's AKS, Google, Amazon, you have a hosted control plane. And in Microsoft's case, we take care of the hosted control plane. We take care of the patching, everything. You don't have to worry about it. And as a result, we don't charge you for it. So all you have to worry about is the agent VMs, making sure that they're up and running. We have health monitoring tied right in, so you have insights into what's going on in your cluster. So now I want to specifically talk about Helm, because your brain might be spinning a little bit, and I'm going to try to simplify this. So Helm is the de facto Kubernetes package manager. It was intently created to simplify Kubernetes because of how powerful it is, but also how complex it is and how overwhelming it can be. But even with Helm charts, because there's still YAML files, deployment files, ingress YAML files, service YAML files, that clip that I showed you a few slides ago of a deployment, all Helm is doing is templatizing that, putting variables in there. That's still complicated. So Draft was created. And Draft was created to simplify Helm, to streamline Kubernetes development. So we'll talk about Draft, but the spoiler is, in 2 commands, I can create a Helm chart in Dockerfile without having to write one line of operations kind of code, right? If I'm a developer, I might not know best practices about Helm or ingresses or networks or services, and I might not really care, but I still want to test everything locally. Draft makes that possible. But first, let's talk about Helm, because Draft is simplifying Helm. Helm is the best way to find, share, and use software specifically built for Kubernetes. You can manage even the most complex workloads because you essentially just have one YAML file that you put all your little needs and wants in, and then all your other templates parse that using the template engine and variables. We know that we can have easy updates. We saw that all I had to do was make a change to my Go code, check it in, and then everything else was essentially a wrapper outside of it and handled the deployment. We saw very briefly that I can do simple sharing because I packaged up my Helm chart as a tarball, so it means I can also have my own Helm repository. It becomes the same as just any other kind of package manager like NuGet or pip or Homebrew if you come from the Mac world. And then we also can do rollback, as I mentioned. So I can very quickly just do Helm rollback, the name of the release, and the version. And it'll roll back to whatever it was before. And because defined in code, I have my image and my image tag, it just deploys it and rolls back to the previous version. So here's a visualization of Helm charts. I have my services. I have my deployments. Maybe I have my load balancer, because in services, I can specify load balancer. Or I have an ingress, and with ingress, I have TLS enabled. I can define all of that and package that up into a little chart. But then what's also cool is just because I've written something in my values file for what I want deployed doesn't mean that that's hard and fast the rule. I can override that at release time, which is how I had 3 different CI servers all using the same chart, all using the same code, deploying out to 3 different endpoints using 3 different variables. And then Draft simplifies this even more, because while Helm sounds cool, I'll then get asked, how do I make a Helm chart? That sounds complicated. So that's where Draft comes in. It detects what language you're writing in automatically, and then it uses what's called draft packs to generate a Docker file and Helm chart for you based on best practices. In fact, I released a video last week where I took a Java Spring Boot application. No Docker file, no Helm chart, not Hello World, a real world application I forked from somebody else's repository. And I did it intentionally. I wanted to see if I'm approaching the problem from a developer, can I use Draft and edit and hack locally on my system and then get the application out onto a Kubernetes cluster? And I was able to do it in 30 minutes. And if you want to check out that video and learn how I did that, it is online. But I'm going to show you a local dev demo of Draft right now. Wait for my little demo slide. All right, we'll go over here. Now the cool thing about Draft is because it is working locally, I'm not interacting with the cloud at all. So here is my terminal. By the way, I do own Badass Terminal on GitHub on my repo. So if you want to mimic that, I made it installable on WSL, Linux, and Mac OS. But I'm going to go ahead and open this application in Visual Studio Code, and we'll take a look at the files that exist in this repo. You'll notice right off the bat that it's really just simple C# files. And I'm not going to lie, this is hello world. Literally, the application is going to say hello world. But the point is not to show you the application in this instance. It's to show you how easy it is to create essentially everything I just told you you can. Now, I'm running Docker. You'll see up at the top in the blue, it says Docker for desktop. That's because I'm connected to a Kubernetes cluster that is running on my Docker instance. So we'll zoom in here, and you can see Kubernetes is enabled on Docker locally on my system. I don't need to set up anything else crazy. So I'll zoom out. I'm going to go over back to my terminal, and I'm going to type draft create. Now that's going to auto-detect my language. It says, okay, you're using C#, you're ready to sail. What does that mean? That means that if we make this bigger, you can see it just gave me a Docker file. It gave me a charts directory. But first, if you look at this Docker file, we see line 1 says you're using this as builder. And then scrolling down a few lines, I have a stage 2 on line 13, technically starting on line 14, where that's my publish stage. Multi-stage Docker files is a best practice, and I didn't have to write it. It gave me basic code. Now, if I wanted to take this and adapt it to my own code, I could make modifications based as what's needed for run commands. As a developer, I would know that. It's anything I would run manually anyway, and set that up in the Docker file. On my charts, I told you how we have templates. And you zoom in here, it now gave me a deployment template. Remember, I've mentioned replicas a few times. If you look at line 9, it says replicas refers to .values.replica count. I said you have one master file to control everything. It's like Lord of the Rings. One ring to rule them all. And here is my ring right here, which is the values file. Zooming out is line 4, which, I'll zoom back in one more time, says replica count. I can change that replica count and immediately increase my deployment or how many replicas I want. All of that was created just by that one command. Now if I zoom out, go back over to terminal, I'm going to do draft up. And this is going to build my Docker image, and it's going to release it. And I will say this is running a little fast because of the fact that I had already run this before, and because of how Docker layers work in caching, it actually just literally cached all the layers, so it didn't have to rebuild. Nothing had changed, which also shows you the power of Docker files and caching with layers. But it now said that it released my application. So what does that mean? When we looked at CodeFresh, we looked at my Helm releases. To look at that manually, I would normally type Helm ls. And that's going to tell me, okay, here's my deployment. I see that I have 2 revisions, probably because I deployed it before I got here and then just deployed it now. But you can see the latest deployment was at 11:51 a.m. Status is deployed. If I use kubectl, get pods, I can see there's my pod. It's been up and running for 46 seconds. Do kubectl, get services, and I see my service right at the top. The service has been running a little bit longer because, like I said, I ran it before. But my point is that this is real full-blown Kubernetes. So if it works locally, and if the application works locally, then it means it should also work the same in the cloud, because that's the value benefit that we've been talking about. So if I know to connect to the application, because I know everyone wants to see hello world, I can port forward and do a bunch of kubectl commands to get over to it. Or I can just use draft. The hacking is done. The 2 commands is done. But if I want to test my application, I can do draft connect. And that's actually going to create a proxy over to the service that's running in Kubernetes. So I just copy this command. We're going to go over to Google Chrome. I'm going to paste that in here. And we'll zoom in super big, hello world, because no one has ever seen hello world before. But to show you that this really is running in the cluster, let's go ahead and kill that. Number 1, you can see the application served and you can get the responses. But now we'll refresh after I just killed that, and the site can't be reached anymore. So it's real live hacking. As a developer, I can check that in. And then ops can come in and make any of the changes that they need to the Helm charts or anything else that relates to the infrastructure that is running in the cloud. Now, there's one more demo that I want to show you. And that's really because as simple as draft makes things and as simple as Helm makes things, this still might be really overwhelming. You might not have a CI/CD server in place, or you might not have maybe an Azure Devops server in place because you didn't know that they worked with these kinds of tools. And I told you you could use a wide variety. You could use Jenkins with Azure DevOps. You can use Selenium, Sonar Hub, so many different options. So to simplify this even further, Azure created what was called the Devops project. So I can start right from my Azure dashboard, and I click on Create a Resource. From there, I scroll down and I find DevOps projects. Once I click on it, I'm taken over into another window where I'm told, get started with a fresh application. We support 9 different applications, I believe. I feel like we add another application once a month, but we see .NET, Node, PHP, Java, Python, Go, Ruby, C, and then I think down at the bottom is even bring your own code. So since this is .NET conference, we'll start with .NET. I'm going to do .NET Core because I do come from the open source world and prefer that. And then from there, I can choose the service. After I've gotten the runtime and the framework out of the way, now it's where do I want to deploy this? And what the Azure DevOps project is going to do is it's going to create everything. It's even going to create my cluster. It's going to create a private registry for me. It's going to create a DevOps organization account if I don't have one, or it'll create a project in an account that I do own, and it's going to do all the hard work. The best part is it also gives me an Azure repo, so I can pull all of the Hello World code out of it, throw my code in, and the Helm charts exist, and the Docker file exists, and it's literally everything that's already wired up, ready for me to get started to play with and to learn. So once I click Kubernetes service, some of you might be thinking, well, maybe the next page is hard. Still pretty straightforward. I give it a project name. I give it an organization, or I can tell it to create a new one. I give it a subscription that I want, and a cluster name. And then I just hit done. That's it. And it'll be the same thing for any kind of project. I could do Service Fabric, or I don't know if you saw, I love this one, they even give you the option to go back to 1999 and deploy straight to a virtual machine. Yeah, I mean, we're really open-minded. But the point is, once you've deployed it, you get a little landing page like this. Because it has to wire up all of that infrastructure and your pipeline, it does take about 15 minutes. And rather than sitting there and watching paint dry, I did it for you in advance. So you can see you get a little landing page of your CI/CD pipeline with your code. That's where you can go out and we'll click on master. You can see it's going to open up into your account. It'll give you a little Azure repo. We'll zoom in here just a second. If I click on .NET Core, you'll see that I have charts.sample app. I have a Docker file right down here at the bottom. It gives me all those files. I can take out their C# code, throw my code in, or whatever language I wanted to use. If I close this, you can see it also gave me a build. So the build that I use to push out Croc Hunter from Azure DevOps uses the same exact steps that this build does. It just essentially tells you how to do it. And it'll run off of whatever is in your repo. So you can see it's running on an agent, which is a Linux agent. You can see that right there. It's doing a build, a push. It's installing Helm, packaging it up, handing it over to release. We can go check out the release. And all of these, I don't know if you're noticing, but I'm just clicking it. I'm not right-clicking, open new tab. These are deep links back over to the actual pages, and they automatically pop out. So if I go to CD and I hit edit, you can see I have 3 tasks because I'm using a hosted build agent, which means it might not have Helm installed on it. If I had my own, I could make sure Helm was set up. But it installs Helm. It sets up Helm init, which is the authentication to make sure the build server can deploy to the Kubernetes cluster. It does all of that. And then it runs Helm upgrade, which was the ultimate command that was being run from Jenkins, Azure DevOps, or CodeFresh. It was just being run from code. This helps you visualize it. And then it gives you a landing page for your resources. So let's zoom out here. I have an external endpoint. I can click this, and it's a little bit more visually appealing hello world. But you can see the application's working, and I have a DNS name that it gave me. It's a really obnoxiously long name, but it still gave me one. And the last thing that it gives me, and this is the part I really wanted to highlight on, is we talked about the importance of application insights and being able to gauge if you're delivering value. This even sets up application insights for you for your application running in a Kubernetes cluster as part of your Helm chart. So you can actually see your server requests, failed requests. You have insights into your running application in that container. And by default, it'll set up your Kubernetes cluster with health monitoring enabled. So you can see your agents, your nodes, your containers, your deployments. You can see all of that visually from Azure as well. So it takes everything we've talked about and it does it for you in 15 minutes and then gives you that scaffolding to scale it according to your needs. Now let's go back over to PowerPoint and we'll just kind of wrap up. So I know that there was a lot that we talked about. I wanted to give you several different tools you can use to help you master your container and DevOps approach when it comes down to delivering value. But I also want to make sure I share with you 5 key best practices for Kubernetes, because I feel like they're often overlooked. The first one, you may have heard me allude to it, but it's build small containers. When you have a small container with a small base image, in fact, I actually made a tweet about, I think it was 2 weeks ago, maybe 3 weeks ago. For anyone in the room that is familiar with open source projects, you might have heard of Home Assistant. It's a really popular Python-based home automation suite, and their base Docker image is 2.2 gigabytes. I had really slow internet where I was, and I was sitting there waiting an hour for it to download. Like, there's got to be an easier way. So I rewrote it with Alpine and utilized multi-stage Docker builds. I got it down to 121 megabytes. The power of multi-stage builds is limitless. The more you use it, not only do you have better performance, you also have increased security because you have a smaller surface attack area. Then you tie over image scanning tools like X-ray or some of the others, and you actually have insight into, okay, there's a problem here. Now I can make sure that surface attack is restrained. Application architecture, use namespaces. All 3 of my deployments, as you kind of saw in CodeFresh when I kind of was looking through, they were in different deployments. You saw a Jenkins deployment. There was something that said Croc Hunter, and then OSCON Croc Hunter. I was able to handle multiple deployments to different namespaces. And using Helm charts is a best practice. It simplifies everything. If you have anything hard-coded in a standard deployment YAML file, and you try to override that, specifically an image tag name based on build ID or other information like git commit SHA, you're going to have a really hard time using sed to constantly parse that in. And I've seen more than once where it doesn't work. And then RBAC. We didn't talk too much about that, but RBAC, or role-based access control, is automatically enabled on your Kubernetes cluster. And you can set up Helm to use RBAC. In fact, that's the only way you set up Helm. But you set up service accounts, and you can tie that right back over to certain roles that you define in your Kubernetes cluster. Be aware of your security when it comes down to your Kubernetes instances and your containers. Don't just think that because it's a container, the host is protected, because that's not the case. You have to still account for it. And that goes back to one of the things we talked about in the very beginning. Both the operations person and the developer needs to worry about security and compliance, whether it's application or infrastructure code. Implement health checks. We didn't talk too much about this, but it was in both the draft files that were generated for you, or in my demo, but then also in the Croc Hunter demo. And that's where I can set, okay, go set this ping test or check this particular directory in my container to make sure the container is actually alive and running. So you set liveliness tests and readiness tests. Setting resource requests and limits. This also was automatically done by draft and in Croc Hunter. So I can say that the bare minimum of resources that's needed for my application is this amount of memory, this amount of CPU. Make sure it doesn't exceed this amount. The Java Spring Boot demo that I did last week that I mentioned, typically when you start off with draft, it's just going to give you like 100 megabytes of CPU and memory, something super small. And for Hello World, that works great. But when I tried that with Spring Boot, it took 15 minutes for the application to start up. So you need to make sure you account for that. I can change it to 256 or 512 by simply changing the numbers, re-upgrading the chart. Just changes to another release. And then if that's too much or too little, you can roll back and play with it again. And then the final, I get asked about a lot, but I'm adamant about it. Be mindful of your services. You can always map external services. Just because you're using Kubernetes doesn't mean you can't use an external database. You absolutely can, and you could take advantage of external volumes. If you want to use NFS storage with it, you can set up an NFS provisioner on your Kubernetes cluster. But also don't rely on load balancers. For the demo that I showed today, I have probably 6 or 7 different applications that are running, all with different DNS names. I'm only using one load balancer. that one load balancer is attached to an Nginx proxy. That proxy is what's actually handling the routing for all of the deployments. And in this next slide is a link to all of my resources. One of the things is a link to that video where I talk about Nginx proxies and load balancers and how to get started. People have asked me, why would I not recommend a load balancer? It's not that I don't, but if you really want to pay for 25 load balancers, number one, they don't scale, and it's, in my opinion, it's a really expensive overhead that doesn't give a lot of benefit. You can utilize Nginx proxy, Istio, Traffic, other tools for Kubernetes, and all of those are buzzwords to look up, that will help you with your traffic routing. It'll help you route services accordingly. You could even do A/B testing and canary testing right from within your Kubernetes cluster when you're managing your networking. You're not just kind of leaving it open. So the link you can go to get everything is aka.ms/jldeen/Croc Hunter. It's going to take you to a markdown file that has, I think it's like 12 or 15 different resources, and you can always check out the Azure Docs pages, which are also linked. Finally, thank you very much.